So when ordering a sandwich, we can choose wheat, white, or rye bread. Then we can choose ham, turkey, bacon, or tofu for the protein. And finally, we can pick American or Swiss cheese. How many different sandwiches are possible? So we could try to attack this problem using the same methods that we've done before. We can draw a tree. So from our starting point, we have wheat, which I'm going to write W-E. We have white bread, or we have rye bread. And then from each of those, we have 4 options for the protein. So ham, turkey, bacon, tofu. And actually, this is really hard. There's not a lot of space. This tree is getting kind of jumbled. And there's actually, this tree is kind of too big to maybe make this method worth our while. And because we don't actually need to give the entire sample space, there might be a different method that we can use to approach this problem. And that's where the multiplication principle comes in. If you have an experiment which has k stages, and you know how many options there are in each stage, that's very important. So we know stage 1 has n1 options. We know stage 2 has n2 options. We know stage k has nk options. If we know all this information, then the number of elements in the sample space is, well, just multiply all those number of options together. So in this case, we can do that pretty straightforwardly as long as we can count the options for bread, protein, and cheese. So the number of elements on our sample space is equal to, well, we have 3 options for bread, then we have 4 options for protein, and we have 2 options for cheese, right? So this was bread, protein, and cheese. And we just multiply them together according to the multiplication principle, and we get that there are 24 different sandwiches possible. This method also works for an example in the first video in this section. The first experiment we did was we flipped a coin and then we rolled a die, and we just wrote down what we got. So in that example, we wrote down the entire sample space. If we wanted to know how many elements were in the sample space, we could write it down and then just count, or we could use the multiplication principle. So in that case, there were 2 stages, flipping a coin and then rolling a die. The first stage had 2 options, heads or tails, and the second stage had 6 options, 1, 2, 3, 4, 5, 6. So in total, that sample space should have 12 elements. And if you go back and look at that video, you will see that there were 12 elements in that sample space. This method does not work in all cases, and we're going to see some examples of that in the next couple of videos.